Dear students, today we discuss assembly language programming of 8051 microcontroller. The first program which we are discussing today is assume that the bit P2.3. What is this? This is a port P2.3. This in the second port, third pin. We are going to configure as the input. Okay, this is the first thing you want to understand. Okay, so and represent the condition of one. Very important statement. It represents the condition of one. If that specific pin is goes high, it means O1 is hot. So we need to monitor the bit continuously in the looping. Okay, so very important. In the continuously we have to monitor. Whenever it goes high, whenever this 2.3 goes high, so we want to send high to low, pulse to port 1.5 to turn on the buzzer. Okay, this is a logic. We need to write the code. First, set B P2.3. That means I configure the port 2.3 as a input port pin. Which port? Second port in the third pin. That's why I set B. Set B means I configure that specific in the specific port in the third pin. I configure as the input. Now we don't know what is the input we are going to give. If it is 1 or 0, we need to check. So here is a label and it will be the loop, right? JNB. What is the JNB? Jump if it is not set. Okay, that means what? If this specific pin is 0, it will be in the complete loop. Why? Because jump if it is not set. So it need to jump only if not set. So if it is 1, it will break this loop and come out. So consider the scenario, it is 0. Initially your input was 0. That means your monitor is in normal condition, right? So it will be keep on following, right? It will be keep on continuously monitoring this particular bit, because JNB means J for jump, N for not set, and B for B, jump if bit is not set. So it will be in the complete looping process. Suppose the 2.3 is become 1, that is high, right? Then what I want to do, I want to come out from this loop and I want to set 1.5. See, that is the condition, right? So I want to send high to low. So first I'm setting 1 logic, then I'm clearing this. So high to low. Okay, to which port? To port 1.5. See these two lines, high and low, right? Why? To turn on the buzzer. Once this pulse on high to low pulse is going to the buzzer, it will do the operation, right? So then start jump here. Where is the here? Here is a loop. So that is completely keep repeating this process. So this is a very small logic. You will try to understand the concept of your input port configuration, set B and clear everything. So next program is the switch is connected to pin 1.7. Okay, the switch is connected, that means 1.7 I need to configure as an input port. Write an 8051 program to check the status of SW and perform the following. What is the SW? So I need to check the SW. If it is 0, I want to send a letter N to port P2. Similarly, if SW is 1, I want to send a letter W to port 2. So this is a logic, very simple logic. See, now switch is connected to pin 1. That means I want to configure the 1.7 as the input port, right? That is the input port. In the port number is 1. In that 7th pin, I need to configure as a input pin, right? That is P X Y. That is the syntax. Here 1 X defines a port and Y defines a pin. In the port 1, the 7th pin, I am going to configure as the input. Okay, that is the first line I'm doing. Set B P1.7. That is, I make 1.7 as an input. Now, see, jump if bit is set. Okay, suppose if 1.7 is 1, suppose, see, just we are assuming that if it is 1, if your input is 1, so I need to jump to over. If your input is not 1, so I need to skip and I have to go here. That means what I, if consider it is low, right? So it will jump only if it is high. Jump if bit is set. So where it will jump? It will jump 2 over, right? But here you consider it is low. Initially it was 0. That means it will not jump. It will skip this section and it will go here. And it will send, that is a n to p2. Here you need to understand one thing. In the previous programs we send only the numbers, right? That is in hexadecimal values, but here we are sending the character. So inside the microcontroller it will be that the equivalent value will be converted into ASCII and it will be processed by the controller. Okay, so it should be, always remember, when you are sending any character it should be passed through the inverted comma. So remember, it should be passed through the inverted comma with the hash. Okay, so this is very important. You need to remember in this program. Here we are sending the character. It should be sent through the inverted comma. It, in the while processing, it will convert it into the ASCII code. That will be while inside the microcontroller. Okay, so that is went to the P2. Okay, so short jump again it will go to, after processing this it is going to again the label, again it will check for whether it is 1 or 0. If it is 1, where it will go, if it is 1, now this then I need to go to the label over. So I need to go to this condition label. Okay, so what I want to do, I want to send the y to port 2, right? So this inverted comma, I'm sending this character, so this will be displayed. So while it is processing, it will be converted into ASCII code, equivalent ASCII code of this character. Okay, then short jump again. So that means in again, every time it will come and check. If 1.7 is 1, it will go to over label. If no, it will skip that instruction and go to the next instruction. So this is a logic in this program. So next program is switch is connected to port 1.0 and LED to pin 2.7. That means 1.7, 1.0 I need to configure the input port. In that you need to understand P10. This is a port. In that 0th pin I need to configure as the input. That means set P1 point. So input configuration is completed. Now I need to check the status. Right, I need to check the status of the switch. Right, so move C 1.0. Right, so what is the program they are asking? So switch is connected to pin 1.0 and LED to pin 2.7. Write the program to set the status of the switch and send it to the LED. So only I want to check the status of the switch, the status to be updated in the LED pin. That's it, very simple. So that means, so I'm just keep on monitoring this port. There is an input port which we configure. So whatever data is coming, status coming, that is going to C. Okay, from the C, it is going to port 2.7 because port 2.7 is the pin we configured a LED. Suppose if it is 1, the LED will glow. If it is 0, it will not glow. Okay, that it just see the program. You need to get the status of the switch and send it to the LED. That's why, see, first we are monitoring the port 1.0 and we are sending to C. From C, again I am sending to the 2.7. Okay, because the 2.7 is the pin where LED is connected. So short jump again. So this will be go to the label again and it will be doing this process repeating. Okay, this is the logic.